case number 2. And when I look at case 2 here, what I'm going to do here is that now I have a cart. So I have a cart moving towards the equilibrium. The other one, I was moving away from the equilibrium. So let's go look at this thing here. So what is my picture here? Well, I'm going to start off with a cart here system. I'm going to put this down here. It's only for scale. And so what I'm going to do here is that I'm going to say, okay, so what does this thing look like? Well, I know that I'm going to have just the opposite scenario. Actually, I need it here. I need to move it down just a little bit more. And then I need this guy here. So what you're seeing here is that the cart is starting where? It's starting at the turning point, and then it's moving towards the equilibrium. So as I look at this guy, I have my springs. So my spring has max stretch right here. And then this guy is not stretched out as much. And so when we look at this thing, what we're seeing here is that again, I have what? I have my equilibrium point. And here's my equilibrium point. Right? There's my equilibrium point. Where's my turning point? This is my turning point right here. So if I look at my turning point, it's going to look right here. So here's my X equilibrium. Here's my X turn. And so the picture that I want you to have in your head is the same picture that we had before, right? It's really this guy right here. This is the picture I want you to have in your head. So if I copy this and I bring it down here, all I have to do now is that I essentially have to come in and just sort of like adjust the size here. And it looks like the size is pretty good. Okay. And so what's actually happening here? Well, what's happening here is that I have my cart doing what? It's now starting at V equal to 0. And you could see that when it gets to the very bottom, we expect what? That the cart would be V max. It starts at V equal to 0, and then it goes to V max. Not a surprise, right? If you go to the bottom of the hill, you would expect to be moving fastest at that point. So what you're seeing here is that you're getting this here now. So if I look at this thing, the displacement is in this direction, and now I have maximum force. Oh, not there. Bad location. Sorry about that.
Bad touch.
And so what you're seeing here is that you're going D, and then I have the spring force. I continue to move here, but this spring force is max because it's at the turning point. And then you're seeing here is that the force and the spring are moving in the same direction. And so when I get to here, I have V max, right? I have V max. And because I have V max, then I could go in and I can do, and I could see from this picture that, of course, it's doing that. Where's my mouse at? Here it is. Right, so we're seeing that exactly like we would expect here. And the reason why this is maximal speed here is that that's where the spring does not act. So if I sort of like summarize what we did last time, we're seeing that we have what? We have max spring force, right? We have max spring force, which tells us that we have max acceleration. And then here, you're coming all the way, the spring force is equal to 0. So in this case, you have Vmax at the equilibrium point. So let's sort of like make some remarks and then start to look at this thing. So in a very analogous way to what we did before, what we're seeing here is that the first thing that I would say here is that the spring force and displacement are in the same direction. That implies then that the work of the spring is positive, so that tells me I should see that the work of the spring is then going to change the kinetic energy to be positive, so it should be speeding up, right? There's an increase in speed. So if I look at my integral here, my integral then says that the work of the spring now is different this time. I don't have a negative. What I'm going here is that I'm going from x turn to x equilibrium, and I'm still getting this guy. So this guy has to be positive. And what you're going to see here is that I get the exact same expression as before, but now the equilibrium and the turn expressions are reversed here. So again, look at, I have that minus sign. So all of the work done by the spring gets converted into spring energy. It's in the spring. And what you're going to find here is that if I now look at the details where I now set x equilibrium to 0, look what I'm going to see. I'm going to get that this expression here is going to give me minus 0 plus 1/2 k x turn squared. And check this out. This is a positive term. So that work is now positive, and as we already stated, this increases the kinetic energy here. So what I need to do here is that, what does this mean here? Because this conceptually has something kind of odd here. And I want to sort of like point it out. You probably already see it, but I think it's worth pointing out here. So now we need to plot f of x versus x to look at the area. So let's look at this thing. So the first thing that I'll do here, as I did before, is that I still have my displacement being plotted here. And this is, of course, the spring, which is minus kx. And of course, this is the equilibrium point, which is 0. So now I still have that same linear line. So let's go look at that linear line here. So what I'm seeing here, let's see if I can plot it to right here. What I'm going to get here is I'm going to get a line that looks to here. And then note that this guy here is the turning point, right? So this guy is x turn. So now what I'm seeing here is that, look at the shade. You might be saying, hey, that area is negative. And I'm going to say, no, it's not. Not in terms of the work, because look at here. In this way, what we're really doing in this curve here, we're effectively moving in this direction. So we're getting more negative as we go like that. Now note, there's no arrow in the area. Maybe what I should have done here is that the reason why this is negative is that the spring force is in that direction, and the displacement is in that direction. So I am going more and more negative. But now what I'm doing in this curve, I'm actually moving in this direction. In other words, I have my displacement in that direction, and I have my spring force in that direction. That is positive. So how can this area that looks negative be positive, right? Because that's what we calculated, right? That's what we calculated right here. So how could that be? Check it out. Look at this point right here. If you look at this point right here is what? More negative. And what am I going towards? I'm going to a point here that's going to be what? Less negative. Even though I'm dealing with negative numbers, that requires a positive change. Another reason to say that when you start talking about energy, you cannot talk about a single point. You need to talk about a change in energy. You know what? I should have been drawing a bar diagram. So let's look at what's really happening here. So if I look at this picture, we know it's a positive work. So what do I mean by that? Well, look at the negative right here. Look at the negative. So if I look at the negative, let's call this point 1, and we'll call this point 2. So let's look at that. So if I look at the energy of the spring, you could see that it's more negative. So here we go. Let's look at it like, oh, let me bring it down more. So you could see that the energy of the spring in this case, let's draw this in a fancy blue here, may look like this. Okay, so this is going to be the energy of the spring at point 1. So here I go, right here. Now, look how I get to point 2 here. That's still negative. I agree. So let's draw this thing again. So then this guy is more, it's still negative, but this is the spring energy at 2. Now, how do I get from 1 to 2? So if this is 4 squares and this is 2 squares, the only way I can do this is that there has to be work. And so when you look at the work in this case has to be what? 2 squares. Where? In the positive direction. So all of a sudden, what you're doing here is that you're moving from a more negative to a less negative. Therefore, that work had to be positive. So when I look at this spring work here, it must be positive. I showed you mathematically. Now I'm trying to show you physics-wise. That's why that is positive work.